Am I doing this right?
Should be hit play.
I think that's just
Okay.
a new one. Yeah.
Was it you personally or was it somebody else? It was?
Oh, yeah. Yeah. Yep. All right, there we go. I'm Ted Troxel, project manager for Think-A-Move, more specifically the software SPEAR, which is speech recognition. Next slide. Who are we? We are a group of 20 people based out of Cleveland, Ohio, and we're coming up with some really innovative automatic speech recognition that forms really well in a high noise environment. We're split up into two parts. So the software side is the SPEAR, and then our hardware side is Milcom. They also do in-ear capture in high noise environments. Next slide. Key sectors that we like to focus on, whether it's in like a sports arena, DoD, military combat, the constant variable in that is high noise, and that's where we like to focus. Next slide. So why would you use speech? It's a natural interface. It's easy to communicate. It's easy to get across a lot of information efficiently. But what's a big problem? And that's noise. We did some internal testing, and we found that commercial off the shelf, which is COTS, was about 50% accurate. Next slide. We have a really modular system, really noise robust. Everything's been internally developed for us, and we like to focus on domain-specific language models. So there's a difference between a general purpose and a domain-specific language model. Two doctors in an operating room are going to discuss things differently or speak differently than they would if they're out with their friends outside of work. This makes a huge difference in speech recognition. Another really big thing is we run locally, right? So we don't need to take, some audio file, send it across the cloud, some big server across the country, process it, and get it back to you. We do it right there on the device, which means that we're secure. You can't penetrate something if you don't have access to it. Next slide. Here we have some numbers. Commands would be something simple like how we, if you were talking to a dog and you told it to sit, it would be able to listen to you. But if you're talking to your friends and you mention how you sat down or something like that, the dog wouldn't necessarily react to that. So commands, we did 450 commands. We found that it was 97.74% accurate and 90 decibels. A good way to think about 90 decibels is that's about the equivalent to driving down the highway with your windows rolled down. And then we did a Black Hawk helicopter at 105 decibels. That one we were at 94% accuracy. And it should be noted that the difference between 90 decibels and 105 decibels is not the same difference between 75 and 90 decibels. So it gets much, much louder as you increase. Next slide. So a use case of this would be for Tatric. There was this problem with medics working on soldiers that were injured. They would take pieces of tape, put it on the soldier's helmet, and then write down what they're doing, what type of medications they gave them. Well, you're kind of relying on the adhesive of the tape to make sure that whoever they sends you off to knows what happened. So we intervened, and we were able to give them a solution to where the medic could continue to work on the patient while speaking what they were doing. And then we handled the back end, recognized the speech, and filled out the TCCC card. Some big challenges with that were technical in the aspect of the memory footprint, right? So we didn't want a huge language model that would take up too much time to work. So we we were able to shrink it down and work on a very small amount of space, which is a really good engineering feat, right? So we were able to use 64,000 words, and we demonstrated this in 2014 and last year at Fort Dix. Next slide. And then here we have a video of the demonstration.
I am here to talk today in conjunction with technology developed for NetWarrior and Think and Move Technology, which is developing a speech-to-talk program to voice fill out a tactical combat casualty repair card pattern. So you start off by saying begin command, cause of injury, unknown, begin command, mechanism of injury, blast, begin command, airway, fright, never mind, begin command, airway, fright, begin command, breathing, needle D, begin command, breathing, chest seal, begin command, circulation, hemostatic, and begin narrative. Patient involved blast injuries, amputation left leg, 2 milligrams morphine administered. Stop narrative.
Yeah, so there's 2 demonstrations in there. The first was the commands. You can see him filling out the form. And then second, he's just freely talking. This allows you to be more free, more natural, because you may not always want to use a command. You might want to do something a little bit more ambiguous. Next slide. Another use case was with the Sierra Nevada Corporation. That was with medevacs. So transitioning from the medic working on a patient to transporting them in a medevac, you would want a medic that's inside the Black Hawk helicopter to be able to also do the same thing with recording with what they're doing. So we were able to integrate into the Gentex headset to where you could push onto a button, talk about what you're doing, and then push again, and then you're now back to your radio. Next slide. Another use was networking on the move. We realized that when you're in a Humvee or another vehicle traversing the desert, it's hard to use a computer. So we relied on what we like to call say it, see it. So these programs, we were able to integrate our software to allow people to either move a mouse by saying mouse left or mouse right, mouse stop, or if there was a button that needed to be clicked, we could say, you know, OK or enter, and then that would act as a virtual click. Next slide. These are some various warfighter events that we've demonstrated our technology at. Next slide. And so here's some more recent projects as well. So we worked with the Department of Commerce to voice enable a specimen app for NOAA. So these biologists would go out on these vessels, capture fish, log the data. The hard part is you're trying to hold a fish, measure it, take all these statistics, and fill out a form. So we voice enabled that application. So they could then, you know, record what they were doing hands-free using a Bluetooth headset. With Northrop Grumman, we voice enabled the 9-line and the VIC-5 protocols. I'm sorry, the devices. Some aviation partners, we've voice enabled the cockpit controls. And then first responders is very similar to the medics. So whether it be police, ambulance, or I'm sorry, police, EMTs, or firefighters that first show up, we like to expedite the process of them working. And then finally, Harman, we did some really cool work with some headsets that was debuted in CS. Next slide. So as a brief summary, we're really noise robust, and we're really specific, right? We performed over 90% accuracy in 105 dBA. We run locally on the device, so we're secure. And we're agnostic to both platform and headset. So it doesn't matter what device you have, we can work with it. Um, Next slide. And then from my colleague and myself and all of us at Think and Move, I'd like to thank you and open up for any questions.
Okay, I get the first question. So I guess I didn't understand it last time, but it seems to be your technology is designed for voice to machine.
That's correct. Yeah. So you can spend all this time logging information, but isn't it just easier just to say it? You know, and that's what we want. That's what we want to do. We want to expedite the process of you using something to something that's really natural, something that we've been doing all of our, well, for the longest.
So the emphasis is on the voice of machine, not necessarily in the noisy environment.
Oh, no, I'm sorry. We
Okay.
also excel in a noise environment.
Can I do voice to human in a noisy environment using your technology?
Are you talking about recording your voice and then sending it over?
Or just talking to you? Again, the environment.
Oh, noise reduction. Yes.
Okay.
So the ability to do good speech recognition in a noisy environment is a noise reduction. So we have some pretty good filtering algorithms that are able to pick out what is and isn't speech, and then if we're missing any parts, we're really good at estimating what should be there.
So would there be latency? So you and I are on the phone. I've got your technology in my phone.
No.
No latency?
No.
Okay. All right. Excellent.
Yes. Yes. That's primarily how we're going to use our data, or I'm sorry, give data to whatever system you would like. If you would like it in some other type of signal, that's definitely possible. But we found that it's easier just to provide text. Any?
So you can fill out a form from in a noisy environment with your voice. Can I tell a machine to do something?
Yes. So that deals more with language understanding and parsing. And yes, those are very real. So with natural language understanding, it allows computers to kind of develop a concept of what you're talking about. And very similar is parsing. So I know you mentioned, if we can't fill out a form, but parsing works as if I'm speaking just